We have designed our engineering system to be highly efficient and recover heat, to perform multifunctions while maintaining the practicality and simplicity, and provide comfort and convenience in an affordable and reliable design that will function for decades to come.
The photovoltaic system is integrated into the passive exterior features of the 4D home, increasing the economic benefit of the panels by using them not only to create electricity, but also as a shading structure. The PV array is mounted on the southern trellis, where it will shade the southern windows in the summer to reduce cooling loads, while still allowing low-angle sunlight to penetrate the windows in the winter to reduce heating loads. In addition, the trellis is mounted above the roof, allowing for airflow beneath the PV array, which naturally cools the panels and increases their efficiency. The PV system is an array of 28 SunPower 240-watt panels. They are made from monocrystalline silicone cells that are 19.1% efficient. The PV system is rated at 6.4 kilowatts AC, a size that guarantees the 4D home to be net zero over the course of a year.
Our 4D home uses innovative solar thermal collectors to help heat our domestic hot water. Unlike conventional solar thermal systems, which have a separate array mounted on a roof, our collectors are mounted directly behind the back surface of our PV modules. As the temperature of the PV module increases from exposure to sunlight, this otherwise wasted heat is transferred from the PV panel to the fluid flowing through the hybrid collector. This heated fluid is pumped through a hot water tank where it transfers heat to the domestic hot water system. The temperature of the PV panel is lower during this process, which increases its efficiency and electrical output. By capturing thermal energy and increasing PV efficiency, our hybrid system can collect up to 3 times the sun's energy as a PV system alone. 6 hybrid panels will provide 90% of our hot water needs during the competition.
Our backup hot water heater, necessary to heat the water on cloudy days and at night, uses a highly efficient heat pump. This unit is attached to a 50-gallon secondary water tank, and using heat pump technology extracts heat from the air in the mechanical room and transfers it to the water in the tank. This unit uses as much energy as 2 coffee machines and is up to 3 times as efficient as a conventional fuel-burning or electric water heater.
A heat recovery ventilator is used to recover heat during ventilation. When fresh air needs to be brought into the home, the HRV uses the outgoing indoor air to preheat or cool the incoming fresh air. The heat exchanger in the HRV has an energy transfer efficiency of about 85%. The recovered heat directly supplements the home's heating load.
The 4D home is heated and cooled by a highly efficient heat pump. In this split heat pump, a refrigerant is pumped between an outdoor unit and an indoor unit. The fluid can absorb heat from the interior air and transfer it outside, which cools the home, or it can absorb heat from the outside air and transfer it inside, which heats the home. Unlike conventional electric heaters that use electricity to create heat inside the house, a heat pump uses electricity simply to transfer heat, making it much more efficient. In addition, unlike conventional heat pumps, this unit is driven by an inverter which adjusts the compressor speed, allowing a varied output based on demand to save energy when possible. The heat pump used in our home transfers 2.9 times more heat than electricity it consumes, making it nearly 3 times more efficient than a conventional electric resistance heater.